Hello and welcome to Module 18 in our C language series. This module is going to focus on sparse arrays, and this session is part 104 for this module. Just a brief introduction. The dynamic allocation system we've been learning about has two major uses. One is to create variable length lists of information like linked lists, which can be used with database applications, for example. The other is to support sparse arrays. But what exactly are sparse arrays? The arrays we're familiar with are something like this, and we all know that this is a single dimensional integer array. Each of the elements in this array can be referred to or accessed using an index, with the first element always having the index 0. The last element in this array, of course, has the index 6. Remember that memory allocated to this array in our program will remain locked or in use throughout the runtime of the program. Important to note that most of the elements in this array have non-zero values, and this kind of an array is referred to as a dense array. Now, the sparse array is the opposite of the dense array. What does that mean? Most of the elements in a sparse array would have a 0 or an undefined value. Now let's talk a little more about sparse arrays. With a sparse array, not all of the elements of the array would physically be present in memory, or would they be necessary. The elements are not sequential, which means they need not necessarily occupy contiguous spaces in memory. The elements are allocated storage from free memory, and that explains why the elements are not sequential. So when are sparse arrays used? They're used when we have applications that have an array dimension requirement that is larger than machine memory can offer, and many of the array locations will not be used. Now, talking about memory requirements, consider this. We know that with a 10 by 10 character array, we would require 100 bytes of memory. With a 100 by 100 character array, we would require 10,000 bytes of memory. With a 1000 by 1000 character array, we would require 1 million bytes of memory. And therefore, if our application is such that has this large array dimension requirement, and many of the locations in the array are not going to be used, that's when we will consider the sparse array. Important to remember that although only a small portion of the elements would actually be in use, the array may appear very large. Now, keeping in mind this last point, can you think of an application, a familiar one, that uses sparse arrays? And I'm sure all of us have worked with a spreadsheet program. So if we talk about Microsoft Excel, for example, we know that it has several rows and several columns, but we never really use all those rows and all those columns, right? Which brings us to the discussion of the logical array versus the physical array. And keeping with the spreadsheet example, the spreadsheet matrix itself is the logical array, and the cells that are actually used by us on that spreadsheet would be what constitutes the physical array. That would actually be present in memory. There are, of course, support routines that would link the logical array and the physical array. Now that we know about the logical array and the physical array, let's talk a little more about the dense array versus the sparse array. This, for example, is a dense array. As you can see, most of the elements have a non-zero value. But this one down here is a sparse array with a lot of the elements, or most of the elements, having a 0 value. And we can represent this sparse array in memory using just the elements that have non-zero values. This would save on memory space as well as computing time. And that would look something like this. What we're doing is we create this array which will store the logical positions of each of the elements that have a non-zero value. So looking at the sparse array, we can see that 5 is the first non-zero value and its logical position in the sparse array are row 0 and column 0. So we store the row position and the column position as well as the value. Similarly, the next non-zero value is 3 and its logical position is row 0 and column 3. We store the row position and the column position as well as the value of that element. Then we have 4, which is the next non-zero value. Its logical position is row 1, column 1. Right? So you can see we've stored those there, and we do the same for all the elements that have non-zero values. Now, keeping this in mind, let's write some code. So write code to print the array representation of a sparse array. The resultant array should have the row and column positions as well as the value of all non-zero elements. So let's now go to code blocks and we can start a new file. And we start with hashtag include stdio.h and then hashtag include stdlib.h int main, and we define our array, which is going to be an integer array. Let's just call it sparse array. And it's going to have 4 rows and 5 columns. And now we have the contents. We need some variables. And now what we're going to do is we're going to calculate the number of elements with non-zero values. To do that, we have 2 for loops. So the first one for the row, so for row equal to 0, row less than 4, row plus plus. And the inner loop for the columns, so for call equal to 0, call less than 5, call plus plus. Just simple loops to access those elements and check whether they have non-zero values. So if sparse array row and column, right, so if that particular element has a value which is not equal to 0, then we increase size, so size plus plus, right? At the end of this, we would have the number of non-zero elements, at which point we can then define our resultant array. So let's just call that res array, and that's going to have 3 rows and size number of columns. Okay, and we need another integer variable. Let's call that z equal to 0, which we will be using shortly, and you'll see why. So for row equal to 0, again row less than 4, row plus plus, and we have an inner loop for call equal to 0, call less than 5, call plus plus. And within this inner loop, we check if sparse array at position indicated by row and column is not equal to 0, then we store the row position, the column position, and the value. So here we say resultant array or res array of 0 z, which is currently 0, equal to row. So we'll have the row position. Then we store the column position. 1 will be the row. Column will remain z equal to column. We have the column position, and finally the value itself. of that non-zero element. So 2 will be the row and the column will remain Z equal to sparse array, and we put in row and column. Right, so we get the value stored as well. Now we've got to increase Z by 1 for the next non-zero element, right? So that we can store its logical position in terms of row and column and its value as well. Right, once we've done that, now you may want to print out that resultant array. So after this, we can say for row equal to 0, right? Row less than 3, remember there are only 3 rows, row plus plus. And then we have another loop for call equal to 0, call less than size now, right? Column plus plus. And within this loop, all we need to do is print. So printf %d and leave a space after that. So we have a space between the values. And then we print out resultant array, indicating the row and column for the index of each element. Now, after this, we can just print \n. That's optional, of course. Right, let's run this now and see the result. And so we have, you can see here, row 0, column 0, and the value 5, right? Similarly, row 0, column 3, and the value 3. And you can position this at the side of the array so that you see that the positions are as per the array, right? 5 is at row 0, column 0. 3 is at row 0, column 3. 0, 1, 2, 3, right? Okay, moving on now. Creating a sparse array can be done using the linked list approach, the binary tree approach, the pointer array approach, or the hashing approach. We're going to focus today on the linked list approach. So how would that work? We of course would need a structure that will hold the information, the logical position of the structure or the element or the cell, if you will, in the array, and the links to the previous and the next element, right? Each structure would be placed in the list with elements inserted in sorted order based on the array index, which would be, if you think about a spreadsheet, the row and the column. Okay, the array would be accessed by following the links in the list. Now, keeping that in mind, let's write some code. So write code to implement the linked list sparse array using a cell name and formula to mimic a spreadsheet. If the user starts the formula using an equal to sign, print the result of the formula just as in Excel, for example. Otherwise, print the formula as a string. If the user starts the formula with a 0, that cell should not be inserted into the linked list. For simplicity, restrict operands to single-digit numbers. Now, one important point to remember is that we're not really writing a spreadsheet program. What we're doing is we're implementing routines that are examples of sparse array techniques. Right? That's important to remember. Now, keeping that in mind, let's go back to code blocks and we can start a new file. And we start with hashtag include stdio.h and then hashtag include stdlib.h. And then we're going to use strcmp, so we will need string.h. We have a structure, so struct cell, that's what it's going to be called, and structure members will be char cell name 9 characters there. Char formula, that's going to be 128 bytes. And then we have our pointer struct cell star next and struct cell star previous. So the code, as you will discover, is the same as we use for a doubly linked list, right? So you should find it familiar. I'm going to call this list entry. And we need some variables, struct cell star start and struct cell star last. Functions will be void insert cell, and that's going to take parameters struct cell star new cell, and then struct cell star star start and struct cell double indirection or pointer to a pointer star star last. And we have another function where we're going to print those cells. So void print cells, no parameters there. Okay. Now we can start our main function. So int main. Now we need some variables here. So char row name, and that's going to be 3 bytes. Why? Because we could have the cell name or the cell row being an A or a B or an AA or an AB, right? Thinking of a spreadsheet here. And of course, we also need in column number. Then we initialize start to null and we initialize last to null. We have an infinite loop or an eternal loop, and within that we have struct cell star ptr1, which we will use with malloc. So ptr1 equal to struct cell star malloc size of, and we can just use list entry then. And now we check if not ptr1, which means that malloc returned a null, then you know what to do. Printf out of memory and exit 1. Now, if malloc does not return a null, then we can ask the user for the row number. Remember that we do not have a user interface here. So we're going to get input from the user in terms of the cell name and of course the formula. So printf enter row 0 to quit. So if the user enters a 0, we'll break out of this while loop. And then scanf %s comma row name. And we check if row name of 0 is equal to a 0, then we break out of the while loop, right? Of course, we need an F flash here, so let's put that in. The next thing we need, that is if the user does not enter a 0, then we'll ask for the formula. So printf, or rather we'll ask for the column first. So printf enter column and scanf, this is %t comma ampersand column name or column number. And then of course F flash stdin. right? Now we check if the column number is less than 10. Then what we're going to do is we're going to add a 0. Why? Because when we're going to print these cell names out in sorted order, if we have a cell A12 and a cell A2, remember these are two strings, right? So using strcmp, we're going to get 2 greater than 12, but we don't want that. So we're going to add a 0 if the column number is in single digits. Right? So that's 0 to, or rather 1 to 9. So if column number less than 10, then sprintf into ptr1 cell name, and the format command will be %s, %c, %d, and those will be in order row name. So that will be A, B, C, etc. 0, comma, column number. Okay. Else, if column number is not less than 10, then sprintf ptr1 arrow cell name, and this will be just %s and %d, right, comma, row name and column number. So I hope that's clear. Then we ask for the formula. So printf, enter a formula, and then scanf %s, comma, ptr1 arrow formula, and then of course fflush. Now we've got to check if the formula starts with a 0. So if ptr1 arrow formula of 0 is equal to a 0, right? Or rather, we can check if it's not equal to a 0, then we can proceed to insert the cell. So insert cell, and we pass in arguments, which are ptr1, comma, ampersand start and ampersand last, right? Now after this, which is after or out of this while loop, we'll check if start is not equal to null, then we can call print cells, right? So print cells, and there's no arguments going in there. And then of course we can end the program. So exit 0, right? Or you can use exit success if you like. And that completes the main function. Now let's go ahead and write the next function, which is insert cell. So void insert cell, parameters coming in are struct cell star new cell, and then struct cell star star start, and struct cell star star last. And within this function, we will need some variables. So struct cell star old and star current. We first check if the list is empty. So if not star last, which means last is null, then we say new cell next equal to null, then new cell previous also equal to null, and then star last equal to new cell, and star start equal to new cell. And then we return. Right? Otherwise, we have current equal to start or star start and old equal to null. So we are initializing current and old, and then we have a while loop while current is not equal to null. Within this while loop, we check if strcmp, so we're checking for a match, that is current cell name comma new cell arrow cell name. First of all, we check if the current cell name is less than new cell name. So that's going to return a less than 0 value in terms of strcmp. That is, then what we'll do is we will say a old equal to current. So we are moving along in the list, and current equal to current next. Right? Else, now within this else, we check if current previous is not equal to null. So again, this code is the same as we wrote earlier when we did or when we discussed doubly linked list, right? So if current previous not equal to null, then current previous next equal to new cell, right? And then new cell next equal to current. And then new cell previous equal to current previous, right? And then current previous equal to new cell, and we return. If current previous is a null, then this is going to be a new per cell or a new start for us, right? So here we say new cell next equal to current, right? And then new cell previous equal to null, and then current previous equal to new cell, and then start or star start rather equal to new cell, and we return, right? Now out of this while loop, right, which means current is now a null, and that means we are adding or appending to the list. So old next equal to new cell, and new cell next equal to null, and new cell previous equal to old, right? And finally star last equal to new cell. right? And this completes the code for this function. Now let's go ahead and write the code for printing the cells. So void print cells, no parameters there. And here we have struct cell star list ptr, or you can use start directly, and here we are initializing list ptr to start. Right? Now, remember in the brief we read that we need to print out the result of the formula if the user starts the formula with equal to 1. So we need to check for that. We're going to have here char fmla of 128. And we're going to have another character variable, and you can call it whatever you like. I'm just calling it sep as in separator. And we need integer result. And we also need one more character variable we need for the operator itself, as in plus, minus, multiply, divide. So you can put that in here. Operator is what I've called it. You can call it whatever you like. Then we have a loop while list ptr is not equal to null. And within this loop, first of all, copy into fmla list ptr formula. Right? Now we check if fmla of 0 is equal to an equal to sign. Then we have sep equal to fmla of 1. Right? And we have op1 equal to sep minus 0. So this will give us the integer value. Remember, formula is coming to us as a string. Right? So minus 0 will give us the equivalent integer, and then sep equal to fmla of 3. That's the third element, if you like, in that string. And then op2 is equal to sep again minus 0. So again we get that integer equivalent. And then operator equal to fmla of 2. Now we check if operator is equal to a plus sign, then result equal to op1 plus op2. Else, if operator equal to a minus sign, then result equal to op1 minus op2. Else, if operator is equal to a multiplication sign, then result equal to op1 multiplied by op2. Else, right, we have result being equal to op1 divided by op2. Right? And then we print the result. So printf %d, and I'm going to leave a tab space, comma, result. Else, that is if fmla of 0 does not contain an equal to, so else we just print the formula as a string, right? So printf %s \t for a tab space, comma fmla. And then of course we need to move list ptr along. So list ptr equal to list ptr next. That completes our print cells function. So now we can run this and see the result. Okay, we have conflicting types for insert cell. So let's see what's wrong here. There's a spelling mistake there. Right, so let's run this again. Expected expression, that's a semicolon there. And we don't have a semicolon here. Enter row. So let's enter a C and a column, let's say 12, and a formula starting with equal to. Stick with single digit numbers. Enter another row, let's say B, and 12. Enter a formula. Enter a row again, let's say A, and let's say 11. Enter a formula. Now let's enter A again, but enter column 2, enter formula, and let's enter C and enter 2, and let's enter this as a string with no equal to sign. Enter 0 to quit. Now we have the results, but we're not getting the cell name printed out. So we have to see whether we have a printf statement there to print out the cell name. Right, so we don't have that, and therefore we're not getting the cell name printed out. Right, so before the string copy, you can say here printf %s, or rather you can have the tab before that if you like, just so that you have a space in between the different cell names that are printed out. So \t %s, comma list ptr arrow cell name. Right, so let's run this again. Let's try that once more. We have C12, put in some formula and enter another one and another formula and a third one and another formula, and let's enter C again with the column 3. Let's enter a formula there and A2 for the column, and let's enter this as a string and 0 to quit. And there we have A02. We have that as a string, and the others we have as a calculation. Right, so I hope that's clear. Now moving on. Modify the code written earlier to locate a cell in the list and remove a cell from the list. Right, so we're going to use the code that we used for deletion in terms of a doubly linked list. So let's now go back to code blocks and modify the code. The first thing we need to do is, of course, declare these functions. So right at the top, after insert cells, if you like, or after print cell, you can say void delete cell. And that's going to take parameters char star cell name and struct cell star star start and struct cell star star last. And we need another function to locate or find the cell, and that's going to return a pointer to that cell. So that's struct cell star find cell. It's going to be the name of the function. Parameters will be char star cell name, which we will get from the user, and struct cell star start. Okay. Now within the main function, we've got to call these functions. So after this, right, you can just put in brackets there and move this statement into that block of code, right? Because after this statement, we will ask for the user to enter the cell to delete. So printf, enter cell to delete, and scanf, comma, cell to delete, which means we need a variable called cell to delete. And we'll have that up here. So char row name, comma, cell or rather star, cell to delete. Now, coming back to that statement we put in just now, that's here, flush stdin, and we call delete cell, passing in the arguments, which are cell to delete, and then start, and or rather ampersand start and ampersand last, right? And after this cell has been deleted, we need to print the list again to see if it's indeed been deleted. So print cells, we'll call that function again, right? Okay, now we need to write the functions themselves. So after print cells, we can put in first delete cell, right? So we have void delete cell, and the parameters will be char star cell name and struct cell star star start and struct cell star star last. Within this function, we have struct cell star cell info, and we're going to use that now. So we say cell info equal to, we're going to call find cell, sending in the arguments cell name and star start. After that, we need to check whether this cell info that is returned contains a null or not. So if cell info is not equal to null, then we check now if star start is equal to cell info, then star start equal to cell info next, right, to save that link. And we check if star start is not equal to null, then star start previous equal to null, right? Because that's going to be the new start, if you will. Else star last equal to null. Okay, so I hope that's clear. Else, that is if start is not equal to cell info, so else we check here if cell info arrow previous is not equal to null, then cell info previous next equal to cell info next. Right? And we check if cell info not equal to star last, right? Then cell info next previous equal to cell info previous. Else star last equal to cell info previous. Right? Once we've saved the links as required, then we can free cell info. So free that pointer, cell info, and that's all. So that completes the delete cell function. Now we can write the code for find cell. So struct cell find cell, and parameters are char star cell name and struct cell star start. Again, we will use cell info. So here we'll have struct cell star cell info. We initialize cell info to start. Then while cell info is not equal to null, within this loop, we check if not strcmp. Remember, strcmp returns 0 if we have a match. So cell name, comma, cell info, arrow, cell name. Then return cell info. Otherwise, cell info equal to cell info next. Right, so we're moving along in the list if we do not find a match. If a match is not found at all, then we just printf cell not found and return a null. And that completes the find cell function. Right, so I hope this is clear. Now let's go ahead and run this and see the results. So creating that list again, Now enter cell to delete, right? So let's say C02, and you can see we do not have that printed there, right? So that completes this program. I hope it's clear to you. Any questions you can post in the comments. Let's now discuss the analysis of the linked list approach. First of all, it's an efficient use of memory because remember, with a sparse array, the physical array will just contain the elements that have non-zero values. Are there any drawbacks to the linked list approach? Yes, of course, because we're using a linear search, as is the case with linked lists. What is the solution then? The solution is, of course, to use the binary tree approach to sparse arrays, which we will discuss in the next session. So this ends part 1 and our session for today. Till the next session, take care, stay safe. Bye.